Hey guys, happy Monday. So today we're going to be going over Chapter 13, Section 7, Translating Sine and Cosine Functions. And just to give you an idea of what's upcoming, some important dates, today you're going to finish Section 7. Next Wednesday, you're going to have a test on sections 4, 5, and 7. Don't worry, we're going to be going back to section 6 after all this, but that test next Wednesday is going to be on graphing. So sine functions, cosine functions, and translating sine and cosine functions. And for this section, our objectives are to graph translations of trigonometric functions and to write equations of translations. So we recall that for any function of f, you can graph f of x minus h by translating the graph of f by h units horizontally, and you can graph f of x plus k by translating the graph of f by k units vertically. And the essential understanding for this section, you can translate a periodic function in the same way that you translate other functions. Each horizontal translation of a certain periodic function is called a phase shift. So we're translating our graph very similar to how we do any other function. So looking at these two examples, when g of x equals f of x minus h, the value of h is the amount of the shift. If h is greater than 0, the shift is to the right. If h is less than 0, the shift is to the left. So that's in this left diagram over here. Remember, when we're talking about h, the original expression is x minus h, so really you're just flipping that sign to tell whether you're going left or right. If it's minus h, you're going to the right. If it's plus h, you're going to the left. And when h of x equals f of x plus k, the value of k is the amount of the midline shift. If k is greater than 0, the midline shifts up. If k is less than 0, the midline shifts down. So now our vertical shifts are telling us our midline, what our new midline is. And that's this graph on the right. If k is greater than 0, we're going up. K is less than 0, we're going down. So identifying phase shifts. What is the value of h in each translation? Describe each phase shift. Use a phrase such as 3 units to the left. So for A, we have g of x equals f of x minus 2. And we're talking about our horizontal translation. So minus 2 tells us that we have a phase shift of 2 units to the right. For B, we have y equals cosine of x plus 9. Plus 9 tells us we have a phase shift of 9 units to the left, just like any other function that we've talked about throughout this year. Another example for identifying the value of h in each translation and describing the phase shift. For A, we have g of t equals f of t minus 1.5. Minus 1.5 tells us we have a phase shift of 1.5 units to the right. So notice also now we're not calling it a horizontal shift, we're calling it a phase shift with our periodic functions. And for B, we have y equals cosine of x plus pi over 3. Plus pi over 3 tells us we have a phase shift of pi over 3 units to the left. So the concept is exactly the same. Now we're just calling it a phase shift. You can analyze a translation to determine how it relates to the parent function. And to do that, we're going to be graphing. So use the graph of the parent function, y equals sine of theta. What is the graph of each translation? So we have the function now, y equals sine of theta plus 3. Sine of theta plus 3 tells us we're going to have a vertical shift of 3 units up, because k is positive 3. So first we're going to start by graphing the parent function, y equals sine of theta. Remember, for your sine functions, your graph is always going through the origin, through the point 0, 0, and then we're following the pattern 0, max, 0, min, 0 for each of our key points. And remember, for sine of theta, this parent function, the period is going to be 2 pi. To figure out the key points, you divide that by 4. So we're increasing in intervals of pi over 2. So I'm just going to label my x-axis with pi over 2. Pi over 2 plus pi over 2 is pi. Then we have 3 pi over 2 and 2 pi. Now for our y-axis, notice the a value in y equals sine of theta is 1, which means the maximum point of our graph is going to be 1, and the minimum point is going to be negative 1. But because we're performing a vertical shift 3 units up, I'm going to add more numbers to my y-axis. So I have 1, 2, 3, and 4. And on my negative y-axis, I'll have negative 1, negative 2, negative 3, and negative 4. So now we can graph the parent function. We're starting at the origin at 0, 0. First key point is at our max. Second key point is 0. Third key point is our minimum. And our fourth key point is the maximum again. So one cycle looks like this of y equals sine of theta. So that's our parent function. Now to graph y equals sine of theta plus 3, we're just shifting each of these points up 3 units. So each of our points is going up 3 units. So we started at 0, up 3 units, brings us to 3. Our key point pi over 2 is at 1, so we shift up 3 units to 4. 0 goes to 3, negative 1 goes to negative 2, and 0 goes to 3. So after a translation of 3 units up, y equals sine of theta plus 3, one cycle looks like this. So here's y equals sine of theta plus 3. So we just graphed our parent function, then translated all of those points up 3 units. Another example with graphing, use the graph of the parent function y equals sine of theta. What is the graph of each translation? So now we have y equals sine of theta minus pi over 2, and the translation that's happening here is a phase shift of pi over 2 units to the right. So minus pi over 2 tells us that we're shifting pi over 2 units to the right. So first, again, we're going to start by graphing y equals sine of theta. So our x-axis has the same intervals, pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. I'm adding an extra value on my x-axis because now we're shifting pi over 2 units to the right. Again, with the parent function, the a value is 1, so our maximum is going to be at 1, minimum is going to be at negative 1. In this case, we don't have to add extra points on our y-axis because we're shifting to the right. We're not moving up or down. So now we can graph our parent function. We're starting at the origin, 0, 0. To the max, 0, min, 0. So here's one cycle of y equals sine of theta. Now to graph y equals sine of theta minus pi over 2, we're just shifting all of our points pi over 2. So our original point at the origin just shifts over pi over 2. So now we're starting here. Our next key point is going to be at 1, next key point is at 0, next key point is at the minimum, and at 5 pi over 2 we're at 0 again. So all of our points just shifted pi over 2 units to the right. And here's one cycle of sine of theta minus pi over 2. So let's use the graph of the parent function y equals sine of theta. What is the graph of each translation in their interval? We're not going to graph these, but we're just going to talk about the translations. So for A, we have y equals sine of theta minus 7. Sine of theta minus 7 tells us that we have a vertical shift of 7 units down. For B, we have y equals sine of theta minus pi. Because it's in the parentheses, we know that's our h value. So minus pi tells us we have a phase shift of pi units to the right. Remember, now we're not calling it a horizontal shift, it's a phase shift. For C, which translation is the phase shift? Obviously, it's B. And D, which translation gives the graph a new midline? That's A, with a vertical shift. So this terminology is very important. Gives the graph a new midline, you have to remember that that is now our vertical shift. That's what's going to change the midline of our graph. And you can translate both vertically and horizontally to produce combined translations. So let's look at the first example where we're combining translations, and you'll notice I already have my x and my y-axis labeled just to save a little bit of time. So use the graph of the parent function y equals cosine of theta. What is the graph of y equals cosine of theta plus pi minus 2? So first we can determine our translations. We're going to have a phase shift of pi units left. That's our first translation. We also have a vertical shift of 2 units down. So I'm going to start by graphing the parent function y equals cosine of theta. And remember, for cosine now, on your y-axis, you're either starting at your maximum or your minimum value. Because it's the parent function, my a value is positive, that means we're starting at our maximum, which would be at positive 1. From there, we're using a similar pattern to what we do with sine, where we go from the maximum to 0, to the minimum, to 0, back to the maximum. So one cycle of our parent function looks like this. Now we can think about our translations for our new function, y equals cosine of theta plus pi minus 2. So first we're doing a phase shift of pi units left. Notice on my x-axis pi is 2 units, so each of my points are getting translated 2 units to the left, and our vertical shift is 2 units down. So this first point at 0, 1, I'm translating from 0 to negative pi horizontally and from 1 to negative 1. For pi over 2, 0, I go from pi over 2 to negative pi over 2, from 0 to negative 2. For pi negative 1, we go from pi to 0 horizontally, from negative 1 to negative 3. 3 pi over 2, 0, we go from 3 pi over 2 to pi over 2, from 0 to negative 2. And 2 pi, horizontally, we go from 2 pi to pi, that's a shift of pi units to the left, and from 1, we go to negative 1. So after a phase shift of pi units to the left and a vertical shift of 2 units down, our parent function, one cycle after this translation, looks like that. Another example where we have two translations, use the graph of the parent function y equals cosine of theta. What is the graph of y equals cosine of theta minus pi over 4 plus 1? So first let's think about our translations. So we have theta minus pi over 4. So minus pi over 4 tells us we have a phase shift of pi over 4 units right. And plus 1 tells us we have a vertical shift of 1 unit up. So now you'll notice in this example, the intervals on my x-axis are different. I'm increasing in pi over 4 intervals rather than pi over 2 intervals. And the reason I did this is because our phase shift is pi over 4. And to keep our graph accurate, I want to be able to see exactly where pi over 4 is on my x-axis. So that's why I did it in pi over 4 rather than pi over 2 intervals for this example. So let's start by graphing our parent function of y equals cosine of theta. So to graph our parent function, I'm just going to zoom in here so it's a little bit easier to see. Remember, for cosine, we are starting at the maximum or the minimum value, so we're starting at our maximum value, which is positive 1. Our next key point is going to be at 0, but remember, now our x-axis is labeled in intervals of pi over 4. For the cosine parent function, it's in intervals of pi over 2. So the second mark on the x-axis is where you want to put your key point. So we go from the maximum to 0 to the minimum, back to 0 to the maximum. So here's our parent function. And now let's think about our translations. So we have a phase shift of pi over 4 units to the right. So every point is just shifting over 1 point to the right and a vertical shift of 1 unit up. So we're going 1 unit to the right and 1 unit up. So we're just going to translate all of these points. 1 unit to the right and 1 unit up. So we go from 0, 1 to pi over 4, 2. 1 unit to the right and 1 unit up to 3 pi over 4, 1. 1 unit to the right and 1 unit up, so 5 pi over 4, 0. 1 unit right, so 7 pi over 4. 1 unit up is 1. And finally, 9 pi over 4 to 2. So after those two translations, here is what the graph, one cycle of our new function looks like. So one cycle of y equals cosine theta minus pi over 4 plus 1 is in green. So now we have the concept summary for families of sine and cosine functions. So our parent function starts at y equals sine of x or y equals cosine of x, and the transform functions look like y equals a sine of b, x minus h plus k, or y equals a cosine of b, x minus h plus k. And the absolute value of a tells us our amplitude. It also tells us a vertical stretch or shrink. 2 pi over b tells us the period when x is in radians and b is greater than 0. H is our phase shift or horizontal shift, and k is our vertical shift, and y equals k is the midline of our function. And some helpful hints to graph translations, because it's not always easy to translate from the parent function. First, you're going to determine the period. Second, you're going to determine the key points based off of the period. So that you should feel comfortable with. We did that in the last 2 sections. Third, if there is a horizontal shift, you're going to determine the new points by adding that horizontal shift to your key points. Fourth, you're going to determine the cosine and sine value, then multiply by the a value. And fifth, if there's a vertical shift, you're going to add to values based on step 4 to figure out the y values of your graph. So let's look at an example. What is the graph of y equals sine of 2? X minus pi over 3 minus 1. And you'll notice I have my x-axis labeled already. These points aren't going to make much sense because we haven't gone through the helpful hints yet, so don't worry about that too much. Looking at the equation for this function, we can figure out a couple of things before getting into our helpful hints. So y equals sine of 2, x minus pi over 3 minus 1. So we know our a value in this case is 1, our b value is 2, our h value is pi over 3, and our k value is negative 1. You have to know all of this information in order to use those helpful hints. So first, we have to determine the period. The period we get by doing 2 pi divided by b. In this case, it's 2 pi divided by 2, which is pi. Second, we have to figure out our key points based off of the period. So we know from the last 2 sections, we do that by dividing the period by 4. So pi divided by 4 gives us increments of pi over 4, which would make our key points 0, pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. And I'm not simplifying any of these because we're going to need to add the phase shift in the next step. So the first 2 steps aren't anything different. Now step 3, we're going to determine our phase shift by adding h. From the equation, we know that our phase shift is pi over 3, so to each of our key points, we're adding pi over 3 to get our new x values, or the points on our x-axis. So we have 0 plus pi over 3, which gives us 4 pi over 12, and I converted everything to be over 12 so that everything has the same denominator. Pi over 4 plus pi over 3 gives us 7 pi over 12. 2 pi over 4 plus pi over 3 gives us 10 pi over 12. 3 pi over 4 plus pi over 3 is 13 pi over 12. And 4 pi over 4 plus pi over 3 is 16 pi over 12. So these are the points that we're going to need to graph on our x-axis. That's why in the original graph, I had everything in increments of pi over 2 just to make it a little bit more accurate. So step 3 gives us our x values. Step 4, we're going to determine the values of sine by multiplying by 1, which is our a value. And to determine the values of sine, we're using that pattern, 0, max, 0, min, 0. So that gives us our new a values. So 0 times 1 is 0. 1 times 1 is 1, 0 times 1 is 0, negative 1 times 1 is negative 1, and 0 times 1 is 0. So that gives us the values of our sine. Now those values of sine are going to change based off of the vertical shift. To determine how they change, we're going to add k. So now we're taking these y values after we've multiplied by our a value and adding k to figure out where our y values are on this graph. So we have 0 minus 1 is negative 1. 1 minus 1 is 0. 0 minus negative 1 is negative 1. Negative 1 minus 1 is negative 2. And 0 minus 1 is negative 1. So these points in step 5 give us our y values for the graph. So you can see our y values, we're going up by whole numbers. Using all of that information, we can graph y equals sine of 2, x minus pi over 3 minus 1. So again, our x values are all over 12, so I labeled my x-axis in increments of 2 pi over 12. And our y values, we can see from the last step, we have negative 1, 0, negative 1, negative 2, and negative 1. So we can stay within that range. When we graph this function, notice I added a little chart to the right just to make it a little bit easier to see. Our x values come from step 3 after our horizontal shift. Our y values come from step 5 after our vertical shift. So these are the points, the ordered pairs that we're going to graph on our graph. So first we have 4 pi over 12, negative 1. 4 pi over 12, negative 1. 7 pi over 12, 0, so that's going to be right in between 6 pi over 12 and 8 pi over 12. 10 pi over 12, negative 1. 13 pi over 12, negative 2. And 16 pi over 12, negative 1. So sine 2, x minus pi over 3 minus 1, one cycle is going to look like this. So that those helpful hints really make it a lot easier to graph without you having to use the parent function. Let's try another example. What is the graph of y equals negative 3 cosine pi over 2 x plus 1 minus 1? So again, I have my graph labeled, but don't worry about that so much yet. Some things we can tell just looking at the equation. Our a value is negative 3, which means our amplitude is going to be positive 3. You get the amplitude by taking the absolute value of a. Our b value is pi over 2. Our h value is negative 1, and k is also negative 1. So now we're going to use those steps. First, always determine the period, which is 2 pi over b, is 2 pi over 2, which gives us 4. We multiply pi over 2 by 2 over pi, which gives us 4. Second step, to figure out our key points based off the period, we do 4 divided by 4, which means our x-axis is increasing in increments of 1. So our key points are 0, 1, 2, 3, and 4. Next, we have to figure out our x values based off of our horizontal shift, our phase shift. So our h is negative 1 in this case, so we're going to take each of these key points and subtract 1 to find our new x values. So we have our new x values of negative 1, 0, 1, 2, and 3 after subtracting everything by 1. Step 4, we have to determine the values of cosine by multiplying by negative 3, which is our a value. Now we're talking about a cosine function. So our pattern is max, 0, min, 0, max. So remember, you have to switch up that pattern if it's a cosine or a sine function. So we're multiplying everything by negative 3. 1 times negative 3 is negative 3. 0, 3, 0, and negative 3 are our original cosine values. So those are our y values. But now we have to take into consideration our vertical shift. So we're taking each of our new y values and subtracting 1, which is k. So our new y values after our vertical shift are negative 4, negative 1, 2, 1, and negative 4. Using these 5 steps now, we are able to graph negative 3 cosine of pi over 2, x plus 1 minus 1. Based off of steps 3 and 5, we know our x and our y values, so we're ready to graph. So our first point is at negative 1, negative 4. Then we have 0, negative 1, 1, 2, 2, negative 1, and 3, negative 4. So one cycle of our function, negative 3 cosine of pi over 2, x plus 1 minus 1, looks like this. You can also write an equation to describe a translation. So what is an equation that models each translation at the top? I just have the parent sine function to keep in mind for all of our variables. Number 1, y equals sine x, pi units down, and translated 3 units to the left. So pi units down tells us that our k value is going to be negative pi. It's negative because we're translating down. 3 units to the left tells us that our h value is going to be negative 3. So we just take our k and our h and plug into the parent function. So we have y equals, our a value is 1, so we don't write that, sine of x plus 3 minus pi. That h sign flips when you plug it back into your equation. And for number 2, y equals cosine of x, reflection over the x-axis, and 2 units left. Reflection over the x-axis tells us that our a value is going to be negative, and 2 units to the left tells us that our h value is negative 2. So when we plug into the equation, we have y equals cosine negative cosine. So y equals negative cosine of x plus 2. Two more examples for writing equations. If you want to take a second to try these on your own, pause the video now. Otherwise, let's get started. So y equals cosine of x with a stretch by a factor of 4 and translated 6 units to the right. So if we have a stretch of 4, our stretch and our compression is given by a. So our a value is going to be 4, and 6 units to the right tells us that our h value is going to be 6. And this is the absolute value of a, because a stretch or a shrink, that negative doesn't affect that. The negative only affects whether or not it is a reflection. So when we plug into our equation, we have y equals 4 cosine of x minus 6. And for number 2, y equals sine of x, compression by a factor of 0.5, 7 units to the left, and pi over 2 units up. So again, we have a compression now, so the absolute value of a is 0.5, and we know it's a compression when it's a fraction that is less than 1. Translated 7 units to the left tells us that our h value is going to be negative 7, and pi over 2 units up means that k is pi over 2. So when we plug into our equation, we have y equals 0.5 sine of x plus 7 plus pi over 2. And that's it for writing our equations with translations. We're going to do one more example with graphing a sine function. So what is a graph of y equals 2 sine of 4x minus pi over 4 plus 1? So we're going to use those same steps that we used earlier, and now it's just a more complicated function. So first thing, before we get started with our steps, we're going to rewrite into proper form by factoring out the 4. So notice in our original equation, we have 4x minus pi over 4. We're able to factor out 4 to get x by itself. So when we factor out 4, we have y equals 2 sine 4 times x minus pi over 16 plus 1. And now this gives us our b value right outside of our parentheses. And using our b value, we're able to figure out the period of this function. The period is 2 pi over b, which would be 2 pi over 4, which simplifies to pi over 2. Second step, we figure out our key points based off of the period. So we do pi over 2 divided by 4, which gives us our x-axis. Our key points are increasing in increments of pi over 8. So our key points are going to be 0, pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. Now to figure out the x values for this function, step 3, we have to add the phase shift. So to each one of these points that we figured out using the period, we add pi over 16, because our h value now, after factoring out 4, is pi over 16. These points are going to be our x coordinates on our graph. Step 4, we determine the values of sine by multiplying by 2, which is our a value. So again, remember for sine we start at 0, then we go max, 0, min, 0. So we're multiplying each of those values by 2 to get 0, 2, 0, negative 2, and 0. Those are our y values prior to the vertical shift. So step 5, to figure out the y values, we have to add k to each of our values of sine. So that gives us the y values for our graph, which are 1, 3, 1, negative 1, and 1. Using steps 3 and 5, we're then able to graph this function. I labeled my table on the right with the x values and the y values that we got in those steps. So now we just have to graph. So our first point at pi, and on my x-axis, I labeled in intervals of pi over 16. So my first point, pi over 16, I'm at 1. 3 pi over 16 is at 3. 5 pi over 16, 1. 7 pi over 16, negative 1. And 9 pi over 16, 1. So sketching this sine function is going to look like this after those multiple translations. And that's it for this section. Remember, the next assessment that you're going to have is next Wednesday, and you're going to have to graph by hand sine and cosine functions. So please make sure if you have any questions, feel free to ask. Your homework is posted to Google Classroom. Good luck.